for this example, we're going to solve a compound inequality. As we can see, there are two inequality signs, and then we have the equation in the middle and two things going on each side of the equal sign. If you want to think about simple inequalities, this would be something like -7 less than or equal to 2x minus 3 and 2x minus 3 being less than 15. So you can solve individually, but in order to avoid that, we're just going to solve simultaneously, and we take the same approach as solving equations. We do opposite operations to be able to solve, but we're going to be performing the operations in both sides, the left side and the right side, and in the middle as we go through it. So let's get started with that. Let me erase this. Here we go. So my variable is x. Remember that when we're solving equations, in this case inequalities, we want the variable to be by itself. We're going to get rid of anything else that's with it, meaning this -3 and this 2, by performing the opposite operation. For this one, you want to think about the example that we've done in class about the GTA. Of course, you want to get rid of this first, of whatever is chasing you, and then you want to get rid of the vehicle that you're driving. So we're first going to get rid of the -3, and then we get rid of the 2. So let's get started with the -3. If I have -3, the opposite operation would be to add 3. And then I have to do that on this side of this inequality sign and also on the other side of the other inequality sign. The middle cancels out, so we just have 2x in the middle, same inequality sign. 15 plus 3 is 18. Same inequality sign over here on the left. -7 plus 3, well, you got to think about owing $7 on your bank account and depositing 3, so you still owe $4 on your bank account. Okay, so now the x is not by itself yet. We want to get rid of this 2. Remember that anytime that there's a number right next to the variable, it implies multiplication, so the opposite operation of that would be division. So we're going to divide every side by 2. Okay, so we have -4 divided by 2, that gives us -2, less than or equal to +2 divided by 2 is just x, less than 18 divided by 2 is 9. So now x is by itself, and now we know that we have a restriction on x where x should be greater than or equal to -2 but less than 9. So let's put that in set builder notation. Remember, we need the little profile bracket, the variable in question, which is x, such that, and then we just bring the restriction. -2 is less than or equal to x, and x is less than 9. And we close the bracket. To put the interval, we already have our restrictions. We know that the left side of it would be -2 and the right side of it would be 9. We just got to consider if we need a parentheses or a bracket. Anytime we see the equal sign, we're going to have a bracket. So on the left side, we have the least amount that it can be would be -2, and the highest amount would be 9. But because we don't have an equal sign with the less than inequality sign, we use the parentheses. So those are interval notation. Lastly, the graph. We know that it is restricted between -2 and 9, and because we have a bracket, or it can be equal to -2, we can use the closed circle, and because it's not equal to 9, we'll have to use an open circle. And that's the graph.